In this example, the signal xt is given and we are asked to find its Fourier series coefficients. We will solve this problem using two different methods so that you can fully understand Fourier series. The first method is the standard and basic approach. It involves more calculations, so I don't really recommend it. But I will briefly explain it so you understand the concept. In this method, we use this formula to obtain AK. To use this formula, we need a few things. First, we need the period t. The period is the interval over which the signal repeats. If you look at the signal, you can see that it repeats every 6 units. So, t equals 6. Then, omega 0 equals 2p over t, which gives omega 0 equal p over 3. Now, an important point about the integral. When we integrate over one period, it doesn't matter where we start. The only important thing is that the interval length is equal to t. For example, we can integrate from -2 to 4, 0 to 6, -4 to 2. All of these are valid because their length is 6. Next, we need to define xt over one period. For example, we can choose the interval from -3 to 3. Then we express xt as follows. Now we substitute this into the integral. AK equals 1 over 6, the integral from -3 to t of xt e to the power of minus jk p over 3 t dt. Since the signal is piecewise, we must split the integral into multiple parts as follows. Each part must be computed separately. As you can see, this led to line calculations, so we stop here. Now we use a more practical method based on properties. Key idea 1. If yt has Fourier coefficients bk and zt has coefficients ck, then y convolved with z has coefficients t bk ck. Key idea 2. If we convolve two rectangular pulses, the result is a trapezoid. By comparing the given signal with this shape, we can identify T1 equal 1 over 2, T2 equal 3 over 2. Now we use a noun result. For a rectangular pulse, Fourier coefficients equal as follows. If you want to learn how to find the Fourier series coefficients of a rectangular pulse, we have covered it in another video. Check the link above. So, for the first pulse, coefficients are sine of k omega 0 1 over 2 divided by k p. And for the second pulse, coefficients are sine of k omega 0 3 over 2 divided by k p. Now, using the convolution property, we multiply these coefficients and also multiply by t. AK equals t product of the two coefficients. Since t equals 6, we get AK equals 6 over k squared times sine of k over 6 times sine of k over 2. For k equals 0, we compute it separately. We use a0 equals 1 over 2 times area under 1 period. The area is the area of a trapezoid. Area equals 1/2 times sum of bases times height. So area equals 1/2 times 2 plus 4 times 1 equals 3. Then a0 equals 1 over 6 times 3 equals 1 over 2. In this example, we solved the Fourier series coefficients using both a direct method and a faster property-based method. We have many more problems like this on the channel. If you find them helpful, make sure to follow the channel.